Okay. We want to find the acceleration of the system, and it says here, it's about to ask you, how is the acceleration of A going to compare to the acceleration of B? Read the rest of that sentence. What does it say? How is this magnitude with those boxes, right? Same process that we had before with those boxes. So, you've got your free body diagram. Over it. You want to find acceleration. This is what you're going to do. Acceleration. In your process of solving process, I would do it. Equations. Write those down. Write down many equations for A. Write down many equations. You're going to need 2 for A and 1 for B. Okay? I'm going to move this down so I got some right. I think the only thing here is the result of the. Yes. Yeah, it has a coefficient of friction of 0.2. Why is that strange? And it's really okay to talk to each other. Take a look. So again, you're going to have those 3 F-net equations. Then we're going to try and figure something out from them. We can do it. Is it moving? I'll give you a hint. What are you trying to find? It probably has to be moving, right? If it's accelerating, it's moving. So just to keep that in mind. Is it accelerating in the y direction though? Is that accelerating in the y direction? No. What are we gonna do? Cry and go home? Yeah. It's not the right answer. It's not the right answer. Where are we gonna go next? I don't know. Pull out that intuition. What do you think, David? What do you want to do?
Find the force of gravity for like each of the boxes.
What's that?
You can find the force of gravity.
Absolutely. Find the force of gravity for each of the boxes, can't we? Yeah. Because the force of gravity, this one's gonna be 5 times 10 and we know this is gonna be 2 times 10. Sure, let's do that. we doing 9.5? Okay. Uh-huh. And then you can do the same thing on box B, right? So that's going to be. I'm going to look at you directions or box B, excuse me. Which is box B accelerating? Down, right? Do you want to call down positive or negative? Negative. So this thing here needs to be negative. What about this one? Negative. And what about this one? Positive. Does that make sense? So I'm going to go ahead and call that on B, the negative 17.8. And then I'm going to make this negative 2 times A. Is that okay with everybody, what I just did there? All right. We did that. Now what might we do? Got an idea, Jordan?
Well, I'm just a little bit confused.
Sure, go ahead.
For ap1 of B, okay.
This one here.
Yeah.
Uh-huh.
So I just isn't mass times acceleration. Oh. Oh, never mind. I figured it out.
Are you sure?
Yeah.
Okay.
Yeah.
Okay. Okay. Go.
Can you set them equal to each other so that f of b on a is in a on b?
Yes, you can. So we can't set these, like these two things equal, but we can definitely substitute or something, right? So you guys are saying this is kind of a cool problem because the way it works out, I mean, this is not anything. Really, we've got 2 equations, 1, 2, and how many things do you know? A lot. That's not what I answered. 2. We don't know this, and we don't know this. Yeah. So 2 equations, 2 unknowns, we can solve it. So you could, I mean, one way, I don't know if you guys like to add your system equations or whatever. I really like the method myself. So let's like figure out what this thing is and solve the F-net B equation for this. Do you guys understand what this and then here are the same? So instead of writing this, I'm going to explode by making it. Okay? So let's play the positive and negative game for box A first. Which way is box A accelerating? To the right. Are we going to call that positive or negative? Positive. So this one's going to be positive. Is the force of this going to be positive? It's going to oppose the force of negative, and FB on A is going to be positive. Is that okay? Down here, because this is box B, and if we look at the picture, box B is going to go down. So the acceleration is going in the negative direction, which somebody told me that is going to be negative. Is that okay? Okay, yeah. Keep asking questions. If you're not sure, absolutely ask them. Move this back so I can see what's going on. Okay. So I'm going to say F of B on A minus, hey, what's the force of friction? What's another statement for it? Yeah. And we know both mu and Fn. Isn't that nice? That's kind of cool. I'm going to change that. What's that? Yeah. So I'm going to take this equation. I'm going to write it down a little lower so that we have space to do it. And instead of writing this, I want to write the thing that it's equal to. This is just a little bit of an algebra mess. No big deal. Can you handle it on a Friday afternoon? Algebra mess on a Friday afternoon? What more could you ask for? I mean, really. If I was going to solve this for this thing, FA on B, so it makes sense, it's going to be negative 2A plus 19.78. You okay with that? And I'm going to throw it into the big one. So we're going to make the ugly equation even uglier. It's not fun. I'm like, yes! Ugly! Here it comes. Here it comes. Negative 2A plus 19.78 minus, well, this is really good, but what was you again? Do you remember? 0.2 minus 0.2 times the normal coefficient. What? 49.45 is equal to 5A. Okay, so it's not pretty. I will agree with you. But how many variables does it have? Sure. You can do it now. I probably, if I were you, honestly, do it. Go, go, go. Oh, I'm sorry, 7. I wanted to subtract. You're right. It would be 7. My bad. Never said that. The beauty. Let me see if I can zoom out. Oh, look at that. Thanks for asking. Is that what you wanted? Now it's really little. But is that better? Okay. All right. Did we find an answer? Yeah? Have you checked it with anybody? Check it with somebody at your table, see if they agree with you. You know, it's always good to double check. Like your head's gonna explode? That's 6.9. Okay. Okay. I couldn't tell if that was okay. Okay, good. Would you like to? Go ahead. Far be it for me to stop someone from solving for something. Oh no, don't solve that. What do we get for the acceleration? Synchronized speaking back there. Units are? Okay. Are we okay? Was it a little bit ugly? Sure. I will tell you that again, I don't know what AP Physics test questions look like. I can't imagine anything hard on the AP Physics 1 test, okay? But you know how to approach it now, right? You know how you might go about it. I wouldn't be surprised to see something like write the definite equation. Generally, they ask you to set things up. They're not going to make you waste time with crunching throughout. Not to say that it's not important. Not to say that you might not have done a test that I asked, but I probably won't ask you quite this time. Okay? I just want you to see how to do it. It's better to have challenging stuff than you agree with that. Okay, so now the reason we did this, partially it's just because it's kind of cool. Partially was to get us to warm up for the lab now. So even though we have love cars, I use the computers today, but I did sign up for it next time. So what I want to do now is to get us ready to use the computers, okay? So maybe on a new separate sheet of paper, maybe, I don't know where you want to write this down and draw a big line in your notes. I'm going to give myself a new page to do machine lab analysis. Okay? And the reason that I really want to go through this with you, when we did the lab stuff, I mean, the question that I asked you to solve, right? How does the mass affect the time? Mass affect the mass affect the time. And you could just plug those in and find the averages and graph it and say, look at me, I'm so cool, I did physics. Or you could take it another step, which is what we're going to have to figure out how well you did that and to figure out how that actually fits in with all this other stuff that we've been doing. Okay? So what I want to do right now is to look at what we're going to expect. And then we're going to take an equation and we're going to memorize it so that we know what we could graph to get a straight line. And then the slope of that line will mean something to us. And then we can figure out how well we did. Do you see? It's kind of cool. I like this lab. So the first thing we should drop because what we so in this lab we have and math one that went around the and down here you have that paper clip with all those weights on it, and that was math 2. And I suppose I could probably draw a table in there so it's out in the middle of nothing. Maybe that would make it better. So just for kicks and to make sure that we're all on the same page, I'd like you to draw a free body diagram of this. I will tell you that the reason that we use the parts we use is because we're hoping that they were very, very close, okay? And they were. So go ahead and draw yourself a little free body diagram. We can write down some mathematical equations. And by the end of this unit, you'll be like, label it. Hoping that by the end of this, like, right, yeah. I was unloading the dishwasher. Oh, oh. What I do? All right. So what forces do you have in M1? Raise your hand if you can tell me what. Ooh, pick me. M2 and M1, which one? Is it right? Awesome. Other forces on M1. Force of gravity. And then what was the other one? Fn. So the force of the surface on one. That's a normal force. Fantastic. And that's it, right? Yay, no friction makes life better. Okay. And then what about an M2? Somebody else, somebody new. Talk to me. Go.
Force of M1.
Okay, and which way is that? Oh. Oops, force of 1 on 2. Fantastic. What else you got? Anything else? What's that? Earth on 2F. FG2. Okay, life is okay. Now, I don't want to do more work than I have to. In this lab, I was trying to analyze how the magnitude of the hanging mass affects the time. There's no time involved with this. Right? What things do you think we really care about? And in terms of forces, what do you think we want to try? Where might time exist? Yeah. Say again? F2 on 1, so tell me more. Mm-hmm. Yeah. This thing, right? Because the question is about mass, but really mass is going to affect this, which is going to affect this, which is going to affect this. Absolutely. So let's take a look. Let's do what we need to do. Net on 2. So that's FG2 plus F1 on 2 is equal to M2 times the acceleration. Whoa, hello. What's going on? There we go. And what else do we care about? Like, I guess what I'm asking is, do we care about these two? We need to change it. Measure the mass of it for later. We do care about this. Let's go ahead and write that. So we wanted to know something about time. Time may acceleration. We're trying to get a relationship between M2, which lives here and here, and the acceleration, right? And instead of writing F2 on 1, here we could write M1 times A. I'm going to go ahead and plug that in. So I'm down here. So F, I'm going to write this as M2 times G. Oh, I'm going to going down, going. Which way is this going? Down. So we're making down negative. Sure. Make that negative. So negative M2G plus M1A is equal to negative M2A. Keep going down, please. Whoa. Is that okay? And so now we got something that's kind of like almost a function or something. We got something that's close, and I'm going to hold on to this. But I think we need to deal with our A and figure out how A has anything to do with distance. Okay? Ready for excited? Okay? I just got big like who are you doing those couple? Do you remember? Because it's two. Right? 5 minutes. I told you when you were in it's not going to take you very long. We'll do it right now. Excited? Are you excited, Cora? She's like, yes, let's do it. Here we go. 5 minutes of fun. I'm gonna like switch to another page. You may want to come back. I want to figure out is really here we go. Like right now. Away. The derivation is not something that you would need to ever recite, but I do want you to know that they don't just come from nothing. It's nice to know that, right? It's not just part of the you know. It really actually comes from something. So here they are. The first one is a pretty basic definition of acceleration. What does it mean for accelerate? Velocity is velocity over what? Time. Velocity over time. Velocity minus velocity and over time. That's the basic acceleration. Okay. A couple of other things we need to know for kinematics equations. All if acceleration is constant. We'll talk more about that later, but I just want to. Do you all know how to find an average? Yeah, you learned that in like second grade, right, or third grade, or sixth grade, or something. How do you find an average of two numbers? And divide by 2, right? So we can say that an average velocity, okay, is equal to the final velocity plus the initial velocity divided by 2. Is that okay? And if we take that average velocity, we can also say that we can describe the displacement of an object over time. Are these two statements okay with people? Yeah. Okay, we're going to put those together right now. Putting those two together, and I'm going to solve that little actually. Yeah. I'm going to solve this equation for delta x. Or yeah, for delta x. Delta x is equal to, I'm going to pull the 1/2 out because I can, Vf plus Vi times 2. Is that okay? Put a box around it because it's important. That's one of the 4. Right? That wasn't bad. That was only 2 minutes. I'm also, because I can, put a box around this equation because that's one of them too. Halfway done. What? Yeah. Just like that. Now, for the best one. You guys know it. You loved it. Your best friendly equation, right? You remember it. Let's do it. Here we go. I'm going to take this one right here. Okay? It's the big one. It's the big one now. And now, let's see. What am I going to do? I'm going to take, hold on. backtrack here. Oh yeah, I know what I'm gonna do. I'm gonna take this equation here and I'm gonna solve it for VF. Is that okay? So I'm gonna ignore this middle part. VF is equal to VI plus AT. Is that okay with everybody? This is just a restatement of this. Here we go. I'm so excited. Are you excited? It's going to be so good. Like, whoa, you're not even going to be able to believe it. What'd you do today, Mom? Mom's asked, what'd you do today? I did this. I derived this equation. Here it is. All right, I'm going to take this thing where it says VF. All right, here it comes. Delta X. There should be a vector, how am I? Sorry about that. Is equal to 1/2, a huge mess. VI plus AT plus VI times T. Well, that's pretty. Wouldn't you say? Of course. River, I'm glad that you agree with me whenever I say anything. It makes everything better. What's VI plus VI? 2VI, right? Whoa, hi. Oh my goodness. We don't have time for this. I don't even know what that was. That was really fun. I know, right? 2VI plus AT times T. Looks like we need to do some distribution, doesn't it? 1/2 times 2 is 1. This is a really long time to do this. 1/2 times 2 is 1, right? And then we've got the VI times the T, yes? Here it is. VI times the T. And I have to distribute again. 1/2 times A times T is 1/2 AT. Times T is, yeah? Look at that. There it is. It was just waiting for you. It was like, I'm right here. Whoa! Whoa! I know. There's one more, but I don't want to speed through it so much that you don't appreciate the beauty of that one. We're going to hold off on that one until next week. And I will see you then. I hope you guys have a wonderful weekend. Thanks.